Okay, let's go with the next topic, that is joint and margin probability. We spoke earlier some topics like Bayes rule and applications, and also Bayesian's belief network (BI). And now let's see joint and margin probabilities. Have you understood what is marginal probability? Last classes. Have you read that? Rather than asking like this, have you read it after the class or before the class? Marginal probability.
Marginal probability is probability of occurrence of an event given the chance of another event.
Joint probability.
Probability of two events occurring together.
Yeah, A intersection B.
Yes, sir.
Okay. So marginal probability will be only one event will be considered or both events will be considered? Only one. And the condition is the one of the events, another event must have already occurred. Okay, probability of one random variable. Let's study this. Random variable, I hope everybody knows. This is a random event that we have picked up that we need to look for. Probability quantifies the likelihood of an event. All of you agree with this statement. Alright? It says probability quantifies, that means it represents them in terms of number of a likelihood of any event. Possibility of any event. When we say it quantifies how likely a specific outcome is for a random variable, such as flip of a coin or tossing of a dice, is also and one of the event driving dice, so which gives us 6 possible outcomes, right? And or drawing a playing card from a deck could be one of the event. All right. So all of them can be one of the random variable. All right. So all of them are random variable which can give any one of the value. All of you following? For a random variable x, p of x, that is probability of x, is a function that assigns the probability to the value to all the values of x. All the values of x. X may have any possible value. Like for example, if you toss a coin, you will have heads or tails. So those two values, this x may hold any one of them at a time. Alright. So what we say here, p of x, that is probability of x, is a function that assigns a probability to all the values of x. Okay. So this will generate all the possible outcomes that the x can hold. Probability density of x equal to p of x. All right. What is probability density? Here, probability density is nothing but how many possible outcomes that you are having. So that may be the a number you can say, or a quantity you can say, or a sample space you can say. That we can consider as one of the probability density. Okay. There are probable options available in toss, tails and heads. In dice also there are possible options available. So those options when I gather it, so I am calling them as probability density. Okay, probability of a specific event A for a random variable x is denoted as p of x equal to A. What we are saying in event A for a random variable x. Alright. Now try to understand what is an event and what is a variable. What do you mean by a specific event A? In example, event. We are just given A as a random name so that we can understand it clearly. So event is random variable X.
Can be head or tail.
Okay, so that variable can hold any one of the values. Okay. For an event toss, there may be a tails here or there may be a heads here. Okay. But the event is toss. Okay. And that we can denote as probability of X equal to A. A is nothing but the event that simply as P of A, representing probability of A. Probability of an event A equal to P of A. What does that mean? Probability of event A can be represented with a P of A. That's a statement here. Okay, it is calculated as the number of desired outcomes divided by the total number of possible outcomes. As we did earlier, we did calculate something yesterday. Okay, we are saying the number of desired outcomes. Okay, desired outcome is what outcome you wanted. Divided by the total number of outcomes. The number of desired outcomes divided by the total number of possible outcomes. So what does that mean? What does it mean? Both the number of desired outcome means what in terms of tossing? If you have only one point, how do you say there is a possible outcome? Only one is a possible outcome because two cases are there. Any one must come. Now the possible outcomes. Okay, then we have total possible outcomes. Total possible outcomes are definitely two. Two cases are there. Any one of them can come, but totally there are two cases. So if you do that, if I ask you, if I toss a coin, what is the possibility that you will get a tail? How much percent you have definitely? 50? Yes. So that's what we are saying. We are dividing something with something, a number. Let us divide that number of desired outcomes is 1 divided by total number of possible outcomes. Head or tail? Two faces. 2. So I have 50% possibility that we'll get a tail or we'll get a heads. Now I have 6 faces in the dice. Now if I play that, what is the possible outcomes?
1, 2, 3, 4, 5, 6.
Total number of possible outcomes. Total number of possible outcomes is 6. So what is the desired outcome? 1 is the desired outcome. So only one face, top face will be just considering whatever the number is, that number will consider. Okay, so that's one face will consider it, but there are 6 faces totally. Okay, so again 1 divided by 6 will be, this will be the percentage that we will get that same number. For example, I want to get a 6 totally because that's the highest number in the dice. I want to get 6, but what is the possibility that you get 6? How much percentage confidence you have that you get 6? So you'll have 0.16%, 16% possibility that you'll be getting 6 every time. Alright, that's the possibility that will be here. Same thing they are asking for cards also, as we saw the example. Drawing a playing card from a deck of cards. So when you pick that card, so what will be that card? So that will again comes down to the number. You pick one card and there are number of possible cards. So 4 cards versus 1 card. Alright? So that's what probability we can check it. Alright, this statement says the same. I'll read again. Probability is calculated as the number of desired outcomes divided by total possible outcomes. Total number of outcomes. In the case where all outcomes are equally likely, that means all the events may likely occur. So in such events or such situations, this formula will hold sway. Alright? Okay. So the formula goes like this: the probability equal to number of desired outcomes divided by total number of possible outcomes. Okay. This intuitive, if we think about a discrete random variable. Discrete means what? Which is not continuous. Okay. Which is having its single value. Okay. Think about the discrete random variable such as a roll of a die. Roll of a die will be giving us one value. For example, the probability of a die rolling of 5 is calculated. 5 is calculated as one of the outcome of rolling as 5 divided by the total number of discrete outcome is 6. Okay. Or 1 by 6 or about 0.16 as we just now calculated. Okay. Or it is 16.666%. That's how we can calculate any one of the number you pick it. You decide that I want 5 or I want 4. So how many 4s you have in the complete cube? Only one time. Obviously, 6 faces are there. One number is on one face. 1, 2, 3, 4, 5, 6. Right? So one of the face will give you that possibility, and that option you are choosing among how many options? Out of how many options you are choosing? 6 options I am choosing. That's why I am going to divide that number. How many options? One option you are choosing divided by 6 numbers. That's how you are going to choosing any of the numbers. So if you have 4 colored boxes, 4 colored balls in a bag, and you have, for example, 6 balls, what is the possibility that you pick first colored box or first colored ball? For example, you have red, blue, green, and black. Okay, so what is the possibility that you will pick for example, blue ball? There are 4 balls. There are 4 colored balls. 4 colored, 6 balls are there. 4 colored, 6 balls are there. Or you take, you make it very simple. There are 3 colors RGB, but there are 6 balls are there. Equal number of colored balls. 2 of contours. 2 by 6. 2 by 6. 2 by 6. Okay.
Or 1 by 3. Only 1.
Okay.
You are picking one ball.
Only one ball. Only one ball. 1 by 6.
1 by 6.
1 by 6 is
3.
This is 0.3. So we have
1, 3, 3.
okay, but I have 2 balls. If I have 3 balls, then it will be 1 by 3. I have 6 balls, but 2 balls of same color. 2 balls of same color, 6 number total.
So 1 by 6.
1 by 6. 1 by 6.
It's like becomes 1 by 6. Because 2 things are happening here. You are picking a ball, and secondly you are picking a color also.
Exactly.
So the first question of picking the ball, get the sideline and picking the color, that becomes the main thing. Sir. So you are finding the probability of picking the color, sir, not the ball. So there are 3 colors are there. What is the probability that the ball belongs to RGB?
Okay, we'll make it more simple again.
Either it can be R or G or P, sir.
Right.
So event is 1, and the sample space is having 3 events. 3 outcomes. That are RGBs. So 1 divided by RGB, that is 3. I think it is 1
Colors are
by
3.
Yes, 3.
Okay. So you make it more simple. We have 3 colors, 3 balls. You tell me which color ball will pick it and what is the percentage of picking. 3 balls are there. RGB 3 balls are there in the back. You pick one. Well, what is the possibility that you will pick red? 1 by 3. 9 if I double the number of balls. Double the number of balls. Same RGB itself, but now earlier there were 3. Now I have doubled them. How about if you
make it 3 balls? Make it 3 balls.
no, only 2 colors if you make it, and 6 balls if you make it. 3 balls, 1 color, 3 balls, another color. Now, how do you use it?
You're picking only 1 balls.
They are picking only 1 ball. That's outcome. These are possible outcomes. 6. Possible outcomes 6. Anyone I can pick it out of 6. Yes. So, but how about the colors?
So if we consider color only outcomes and positive outcomes, 1 by 2.
1 by?
If we choose
1 by 2. Which colors?
color as effective.
Color only I am saying.
Then 1 by 2.
1 by 2. 1 by 2 colors. Okay. So if I do 1 by 2 colors, I will have 50% chances that I will be picking any one of the ball, 2 color balls. Same like tossing a coin. Right? In tossing a coin, it is that the coin faces are only 2, but repeatedly we are tossing. Here already the options are ready. Okay, options are ready, and we are trying to pick something. That's what making changes. So this number of balls that we are saying, or number of balls that are increasing, are your sample spaces. Okay, you need to understand that. Sample spaces are the possible outcomes that we are considering, the space we are considering, in which you are going to operate. All right. Okay. The sum of possibilities of all outcomes must equal to 1. All of you agree with the statement. If we say sum of probabilities of all outcomes must be equal to 1. That is 0 to 1 is the probability range. Okay, if not, we do not have valid probability and we are somewhere wrong. If it is not making it 100, that is 1. Sum of probabilities of outcome equal to 1.0. Probability of an impossible outcome. Probability of impossible outcome will be definitely 0. If it is impossible to roll a 7 with a standard 6-sided die, right? A probability of impossible outcome 0, 0. Probability of certain outcome is 1. For example, if it is certain that the value between 1 and 6 will occur when rolling a 6-sided die, then there is a possibility of getting an outcome. That's what we are saying. Probability of certain outcome is 1. Certainly it is 1. Any one of the outcome is coming, then it is obviously 1. Probability of certain outcome is equal to 1. The probability of an event not occurring called the complement. If something is occurring and something is not occurring, so there will be complementing. Obviously, opposite of that. Okay, you can calculate the probability of the event with respect to 1 minus the probability of the event will give you the other component of the event. Okay, 1 minus probability of A will give you the probability of probabilities complement. Probability of not rolling a 5 would be 1 minus P of 5. You understand the statement? For example, probability of not rolling a 5. I will not be getting a 5. You need to tell me how I cannot get the 5. How it is possible that I will not be able to get 5? The negative component of probability of trying to check.
Sir, here rolling means yes.
No, rolling means that. Roll basis. The die rolls. Okay. 1 minus probability of A, you can do with the help of 1 minus probability of 5 or 1 minus 0.16. That was the probability of 1 divided by 6.
Sir, we are 10, 3, 6 ways. 5 is not occurring.
Correct.
That is the
One possibility we are removing from the whole possibility. The one possibility I don't want. I don't remove 4, 3, anything. Alright, that's negative component of that. So that we are trying to check. So what is the one outcomes probability that we calculated in calculator is 0.16. That we just subtract from. Okay, 1 minus 0.16 or about 0.833% is the probability that we will be getting other than 5, not 5. Probability of not event A equal to 1 minus P of P will be the minimum.
Sir, here 83.2. P is not, 5 is not occurring.
Apart from 5, all other things are occurring. What is the percentage of all other things are occurring? That's what we are. One of them is obviously we know that's 0.16, 60%. One we are removing, so 5 is not occurring. Other elements are occurring. We are not saying it will not occur. We are saying how much percentage probability is there that 5 will not occur. If 5 will not occur, other things will occur. Other things will wait.
5 will not occur, then 1 is occurring.
Obviously.
2 is occurring, or 3 is occurring, or 4 or 6. So when all is concerned, we have to have the probabilities of 1, 2, 3, 4, and 6.
Yes. So each one of the probability is 0.16.
So then 1 divided by and 1 minus 1 divided by.
Same answer. Same, but as we are saying here, we are subtracting it from the total probability. We are making it 1 minus probability of something. Okay. Note that we are familiar with the probability of one random variable presenting, and let's consider the probability of multiple random variables. I hope you understood one random variable's probability calculation. For example, okay, likely to work with the more random variables. Given table of data, such as an Excel sheet, each over represents a separate observation or an event, okay, or a record. Each column represents a separate random variable whose values are going to change every time for all the variables. You understood? In an Excel sheet, if you have a table of data, then we will have a row as an event or an observation, and the column in that record will be one of the random variables. So we will have in one event there are lot of variables. Alright, so those variables could be many in number, so that's why many random variables we are considering. Variables may either discrete, okay, or single value, or meaning that they take a finite set of values, or continuous values, meaning that they take on a real number or numerical value. Okay, so we are interested in the probability across 2 or more random variables. So we are saying this is complicated. There are many ways to random variables to interact with, and we are saying which impacts the probability with respect to multiple variables when they change their values. Okay, to discuss further probability, we just need to have 2 events presently. We just don't go for more than 2. Just for your understanding, one of each variable x equal to a, y equal to b. Okay, although we could just as easily be discussing a group of events for each variable, we will be able to take only x and y present. There are 3 main probabilities we might consider: joint probability, probability of events A and B, joint probability. Then marginal probability is probability of event x equal to a. X is a random variable, a is my event, given variable y. means y is already available as an evidence, and then we are trying to find out the random variable x on the event of A. Alright, then we are calling them as marginal probability. Trying to find out the probability of one variable, for example A, when y is already given, or trying to find out x when y value is already given. Got it? We are trying to find out the value of x when y value is already given. That's the same thing. So we are calling them as marginal probability. Conditional probability. Look at the dependency. Probability of event A given event B. Here we are not considering any x and y. We are just considering two events purely. Okay, don't get confused with that. Conditional probability is probability of event A given B. How do you write this?
A bar
A bar B or B bar A?
B bar A.
Which is given here?
A given event B.
A given B. So A bar B. A bar B is the right one. Okay, these are the type of probability form the basis or basic of or base for much of predictive modeling. Predictive modeling with the probabilities. One is classification and regression. Do you understand both the words? At least. What do you mean by classification? You classify what? Example events. Event means what do you trigger? Huh.
A class, B class, C class. In the college, sir.
Huh.
Sir, that we are dividing the classes.
Classes.
A,
Divisions.
divisions.
Okay. So why do you do that?
Because to write some course. Spaces.
Okay, but all of them are students only. But there is no reason to divide them other than the space. Yeah. Any other? You need to have a reason or a property based on that. You can say that I have changed this one. I have identified this one like this. Can you identify desktop and laptop two differently? Or both the same?
Depends.
Because of their making, you differentiate them. Okay? You can classify a wireless mouse and a wired mouse. Okay? You have a reason to tell what it is strongly. Alright? So that is how we say we classify based on some attributes. We need that attribute strongly available as a proof. Why I am saying that? I need to have a strong statement. Okay, this doesn't have wire, so I am calling it as wireless. Okay, understood, and I can believe on it. All right. How about the phone and tab? You differentiate. All right. Tab and laptop. You differentiate. You have a reason. So that's how you classify based on the reasons that you have. In machine learning and deep learning, you do the same. You will give a reason in terms of their properties. Alright? Based on those multiple properties, they differentiate. Okay, both cars are having same property, so both are car only. I can say no, they are not same car. They are different car. So there are 1,000 properties. 900 property of both of them are same. In 100 property, there is a mismatch happening. Alright? So then we classify them as this is the one, this is the one. Alright? Okay. So that's how classification will be a property based classification. How about regression? Matches the value in one value, another value. This is classification. This is a classification. You're classifying based on some property. Some property means you are classifying based on the shapes you have in this one. Okay? We have binary classification means only two. So only two objects we are able to consider. In other way, I can say it is true or false. Only two. Right? This will also be one of the example in your day-to-day life. You will see emails. In email, I as an algorithm have to decide whether this email is a lottery email I get it, like you own something like this. Then I have to decide as an algorithm whether this is a legal, a legitimate email or is it a spam email. By reading the email, I can read that okay, this is a similar to that fraud email that we have read it earlier. So spam, the email will be sent to spam by default. Okay, so it has to decide spam, not spam. Right? That is classification immediately. That's how it is binary classification. Yes or no. Here we have multi-class classification. We have multiple classes, and then we will be able to classify which class this object belongs to. All right. That's how we can be a classification. Okay, you can look at this one. And this is a classification. We are drawing a line to classify them. And here is the line which is trying to connect to all the dots, and which are the near dots are there, that it is trying to connect it. So regression will give you the values as a output. Okay, or it is trying to build a connection or relationship between multiple variables coming in the way. It is trying to find out the pattern in the random data. Randomly dots are there. So line we are drawing. The line might be in that direction, or the line might be like this. But where that line has to be there and how it has to connect, that will be told here in the regression. To find out the pattern in the data. This is a new regression. This line in future in future modules we'll be going to write this line. How to write the line and how we will draw the line. We're going to study. This is the line which is trying to connect and trying to build a relationship between the multiple variables in connection with the line as a base. Then from the line it is trying to connect the nearby distance with the points. All right. So regression will try hard to create a relationship between multiple values or variables available with the help of that line. All right. Why does it do and why it is doing that in the question first? In generally, how can I understand that? Like this: if I have 100 people's height values in the Excel sheet written, listed out. And I wanted to find out another person's, last person's height, 101% height. And I have not only height, I have his name, his date of birth, weight, everything. I have it. And everybody's date of birth, everything they have it. Now, I will supply this 400 people's data to my regression algorithm. And we try to find out the height of the last person whose data is missing. It is doing that by plotting all those height points like this on the random plot and trying to draw the line. And then try to find out that probabilistically all these people's age is this one and this is the height, age is this one, this is the height. Y value is this one, X value is this one. Y value is this one, X value is this one. So I am getting coordinates, XY coordinates, X, Y, nearby to the line. So this person is also nearby line. So probably that this is the person's height might be this much only. So it is probabilistic value. Okay, how much probability the diagram says? It says this is error term because the distance between the line and the pointer is very much high. That's why they call them as error. That means we cannot consider that value as a prediction value. Alright. Nearby value if it is there, we are making them green. Look at here. This is the green place where we can have small values which are having shorter distance between them. Alright. Then we can say them as a values we can predict it in this space. All of the values are to be given. Okay. So we will be able to understand how the values could be used to regress in terms of multiple values and how. Is it blue? Okay. Okay. So that is how regression will help you in trying to find out the unknown values based on the values that you already acquired and trying to find out the pattern between the multiple cases. That's how it goes. I hope all of you understood what is these two words, classification and regression. For example, the probability of a row of data is a joint probability. The row of data in Excel sheet we are talking about. Just now we said right, we have Excel sheet. Probability of row of data is joint probability across each input variable. Probability of specific value of one input variable is the marginal probability across the values of other input variables that we have in the same set. First statement. Probability of a row of data. What is this row? Where is this row? Where is this row available?
Row will be in the Excel sheet.
Excel sheet is there. So in that there is a row. Okay.
Having 4 columns.
Okay. For example, 4 columns.
Height, weight, color, marks.
Okay. The row data, probability of row data is the joint probability across each input variable. If you consider all the variables, then jointly all the variables will give you a joint probability. Okay. For example, we took just an example of pointers. Okay. We told that whether it will give you tails or heads. If I tell you, I will not take 1 point, I will take 2 points. Now you have to tell me how many times I will be getting head at a time. Only once? Only once I will get. Probability, percentage. Head, tail, head, tail. How many combinations? 4 combinations. 4 combinations and only one outcome I am asking. Right? So that will be one of them. So we are trying to say the joint probability will be your probability will be dependent on multiple values or multiple variables which are changing values. So here, something will come head. So heads and tails both are participating in giving you the one value of probability. All right.
So probably like right now is two events.
Two events.
But AM only one way activity is that.
Two events randomly. This event is irrespective of this one. First you earlier told one event. Good. I have two events now. Second event activated. One more person I will tell you to toss two more points. So now 4 events activated. Okay, we are saying probability of row of data is joint probability across each input variable. Okay, probability of specific value. Now, specific value of one input variable is the marginal probability with the help of other. Okay, across the values of other input variables. The predictive model itself. Have you understood second one? Second statement. What we are saying? We say probability of a specific value of input in an Excel sheet is the marginal probability across the values of other input variables. We are having other variables, but we are looking for only one value's probability. I told I have 4 columns in Excel sheet. I am taking only one value in one of the columns. Okay, and we are trying to find out its probability. So, in connection with all other values available, this is not known, but other variables known, and I am trying to find out one variable's probability. Then I am saying that it is having the marginal probability. Okay, we saw the same marginal probability in terms of photo also yesterday and the diagram. Okay, if you want, I will just pick that diagram and show it to you. Which one we pick? This one we pick? Yeah. You can understand this? Marginal probability. P male. Probability of male. Totally. Whole thing. Okay. Total number is 200. Out of 200, 102. So 102 divided by 200. How much? We have calculated ready. Number 2. 102 divided by 200. I want 0.5. So we are talking about how many males are there out of 200. 51% we have males. Just saying. In connection with other variables, we are trying to find out one or two. What is the percentage of probability of that? That's what we are saying. It is a marginal probability. Marginal probability. Same thing for all the 4 values. So, probability of passed students. How many of them are passed? Okay, irrespective of gender, male or female. So then we have 114 people totally passed and 86 failed. So what is the probability of passing? Average passing. 114 divided by 200 give me 0.57. 57% people have passed. And then 14 in terms of 200. 100 means 50%. 14 extra. Okay, so we'll be having 57% passed. So we are calculating with the help of the margin, with the help of the total probabilities, total possible options, total outcomes, and the desired outcomes. Okay. Some more example. Yes.
So in that example, marginal probability. What is the probability?
Single values you are taking in a row and in a column. And you are trying to find out.
We are collecting the single row, a single column, and each element.
Yes.
We are calculating the value.
Yes.
That is the margin.
Correct. We are not taking whole thing as a one box. We are taking one part of it and we are trying to calculate with respect to the other one. We are leaving other one. Some more example, if you have, I can take it. Football is there. We have margin probability. This you understand? Study time in minutes. This marks scored. And you have totals. Here total, here total. So this is marginal probability distribution. Okay. As you said, Excel sheet. This you consider the Excel sheet as we speaking about. Same thing you consider and try to understand. This is my one row. This is my one row or one event which we are considering. Alright, representing one event, one row, one student's record. Not one student record, it is the percentage that they have taken. Marks scored in terms of 90 to 100 people have taken who have studied 26 to 50 minutes time, and those who studied 51 to 80, 75, 87, 76 to 100, 0.04. The probabilities. So high probabilities here, not here. This one. So 50 to 59 marks scored. Those who studied last minute, 0 to 25. Okay, so individually they have been studied, right? So all the variables have been considered here. And that has been considered as marginal probability. And here we have calculated totally with respect to the mark score, and we have the marginal probability.
So every time we have to take the total info and total column. And that should be
Single column value we have taken. Single column value we have taken. So if you have only one record, one event here, and that's what I told you earlier that in the slide that we have to study multiple random variables. But for your study, we restricted it to two events. Yeah. Okay. So here we have taken events 1, 2, 3, 4, 5 events we have taken. So 5 events at a time you are doing. Don't do all 5. Do only one and try it. Random variable only one is there. 2 you take it. Maximum. A and B you take it event and try to understand. They have taken more number of them. Multiple random variables that initially. Yes. Here we go. Okay. Probability of specific value of one input variable is a marginal probability across the values of other input variables. Okay. Across we are saying, so we'll be going to take all the variables. Okay. Next, predictive model itself is an estimate. What does that mean by estimate? We are saying predictive model itself is an estimate. You have came across this thing when you go to shops to make estimate initially before buying something. So why do you take budget information? Budget equal to this. Okay, so actually what you're trying to do internally. Ajay, for us. system of taking the quotation, or why do we take estimate? Why do we take that? Yes. So you are checking the best fit number. Maybe. Anything else?
It matches the requirements.
Yes. So you are trying to understand how this number, the number given by the shop owner, is going to fit in my range of numbers that I have decided. And that you are doing by taking some sample values, and you are actually predicting the values from the market to your budget. Okay. So you take the estimate because you have now, initially you don't have any number. You are very much blank. When you went to one shop, you got some idea. One number is there, okay, this is the number. But still, if I ask you, is that the number in the market? Is this the right estimate? If I ask you, you have 50% doubt. And 50% yes. Because you have only one estimate ready with you. I want to reduce my unknown knowledge. So what I do? Next shop I do. Just to reduce my percentage of unknowingness. Okay, to increase my confidence. So I'll go another shop, and independent of that shop doesn't know this shop. Independently, I am taking one more quotation, one more estimate. So that person gives little varied value. Now I again alerted. Okay, so the value is less here. So again, some other shop will also give me less value. So now you started predicting. Okay, this temporary prediction, but the prediction is started. Earlier we had one data, now you have two data, now you want third data to cross verify. When you take the third one, you definitely understand that my possibility of giving or purchasing the goods in the right price has increased. Alright, that is what my estimate will give me an edge over prediction. Right? Okay, so that's what we are saying. We are making a statement that model itself is an estimate in the figures. My predictive model is an estimate. Estimate is simple value I am taking, whether it is right or wrong, but I am taking some values. When I take one value, two value, three value, I will be able to predict something marginally. Okay, the predictive model itself is an estimate of the conditional probability. Conditional probability, which says I am going to find out the probability of A with the help of B. Do I have B? Yes, I have a B available with me. I have three quotations with me. I want to find out my value, which value I can fit on. Conditional probability of an output given as an input exam. Alright. Joint, marginal, and conditional probability are foundational keywords in machine learning. You understand that? Because when we speak about machine learning, we speak about learning. When we speak about learning, we speak about input data like let's apply. When you are telling your machines what you already know, that means you are giving some clue about already that machine has to tell. Alright? If you ask machine to calculate 1 plus x equal to 2, you have already given a clue that my answer must be 2, and the user has already given me one variable for input as a ready made value. When already given, you are telling me to find out x value, 1 plus x equal to 2, but what 1 will become? 1 will become my training data. Two machines. The knowledge is there, the knowledge is right, like question answer, you given it to machines. One way you are already given, read it. Now you just have to ask the question related to the answer that I already supplied. Alright? Then 1 plus something it has to add so that the answer could be 2. It will definitely add 1 and give you the answer. You try again. It will try 0 and check whether it is 2 or not. It will try 1, then it will check whether it is equal to 2 or not. When it's say equal to 2, it's learned from that. Alright? That's how it is going to give you the prediction values based on the probabilities and conditional probabilities. Alright, so we just now told about joint probability with respect to multiple variables is going to give you an outcomes. Alright, and I want all of you to understand and also read lot more about, there are a lot of articles available on joint probability, marginal probability and conditional probability. All of them are very easy and very easy to understand, provided you understand them separately with example. Small example, two examples. One small article, 2 minutes. Finish. Okay. Joint probability of two variables. Joint probability of two variables. Just now we saw an example. Let's go some more detail and let's understand. We may be interested in the probability of two simultaneous events, A and B. Example: the outcome of two different random variables. Probability of two or more events is called a joint probability. Okay, two or more random variables is referred as joint probability distribution. Okay, joint probability distribution. Obviously, we are going to distribute the possibilities on two variables. I mean, you are depending to find out probability on two variables. You are depending on two variables. All right. Okay. So when you say the variable come, so you depend on the air, you depend on the humidity, two parameters I'm taking. Then you say, okay, variable come. One of the parameters, if I take it out, you will not be able to actually decide. And give you two parameters, you decide that. So we are saying jointly this parameter humidity, this parameter air, together deciding one thing. All right. Okay. For example, joint probability of event A and event B is written formally as P of, that is probability of A and B. Then we are calling them as joint probability of A and B. The and or conjunction is denoted using the upside down capital U operator or caret operator or cap as you usually say, or something like comma. We can represent like this also: probability of A caret B. Conjunction is the keyword you hear in a mathematical logic. How many of you studied mathematical logic states? And or logical states. Heard of it? Those who learn, they only learn or and, all of them, right? So this is conjunction or and we call. Already name on that. Okay. Conjunction, you can read them as and, no problem. A and B, A conjunction B.
So
you can
becomes joint probability.
correct. Not probability. The joint probability for events A and B is calculated as probability of event A given event B multiplied by the probability of event B. We saw that formula also earlier. Joint probability. Like this, you can understand the formula. Probability of A and B equal to probability of A given B or A bar B multiplied with probability of B. Okay. So this must be available to you as an event or a probability you should know, and you are trying to find out the probability of A. Okay. Both of them will be calculated together. That is how you are going to calculate a joint probability. Now, how many of you understand probability? How do you understand? Can you give me an example of that you have not discussed in the class? And those are not given those examples. Those were given examples earlier. They must not give others to share. And if all of you become silent, then it means that all of you are giving the exam. Probability.
So crops in agriculture,
Okay.
crops we can probably we can get the good crops and
This time, good crops can come. Okay. So, what are the random variables that you look for when crops are growing?
fertility is
One particular
soil
site,
is fine, and it's the health of going
health of the plant.
plant,
Okay.
proper water supply,
Water supply to the land. Okay. Then
humidity
humidity and air.
and rains.
Rain is important.
These
Only when,
borewell is not there.
Okay. When the actual water is not there, when the water supply is not there, rain is dependent. Okay. So if rain is not there and water is not also not there, one of the variable I am just removing from the crop system that you're telling. So what will happen?
The fertility of a crop will become less.
But the soil is good.
Water is very much important to grow.
So it is a joint probability. So both of them are dependent. Alright? Both of them together has to be known. Okay. Okay. Any other?
So you are taking example here, sir, and outside, both are different. Because A is a with the help of Venn diagram, A and B.
Okay.
Both are overlapping.
Well, I think I made the same one.
The intersection point is the joint probability.
Alright.
We are collecting the red box and white box.
Correct.
Who matches both red and white box.
Correct.
That is the intersection.
Correct. Exactly.
But it is the difference, sir. In the outside example, has a difference.
Outside example means
Now he gives
he told okay. So what you have understood that it should not be there. For example, he told something about crop and he's telling about that if rain is there and water is there and the soil is good, then the crop will grow.
how both are not
Related at all, yes. Okay. So we have taken two variables here as red balls and green balls. Two balls. And we are trying to understand where those green balls are available, right? In the middle. Okay.
who likes both red and green.
Okay. Here we have red balls.
Green balls. Red and green. Some people likes red and some people likes green. And both some people like both red and green.
Exactly.
So how it is related to eager example?
So he has taken more than two. If he has taken soil and what you can say water, soil and water separately they are available. Some of them will only need the soil and its fertility, like in desert. Okay, they take the air from the air and they take the moisture. They only need soil. They survive. And here water. In water, deep down sea, there are plants. Okay, algae is one of them. Who only need a surface like stone and they start growing. That is this one. And some of them are this one that is telling. In his farm, this is existing. This is Ajay's farm, which needs soil as well as water. So we are saying, he's saying, we have the fertile soil. So I'm saying 70% I have the soil which is fertile, okay, which is not having the water. Here there is a water and no soil and very less soil. Right? And we are matching that thing and we are saying here we have, for example, 30% or 40%. This area is there. Okay? And we don't know this one. So we are trying to find out this one. When this is given, and this is given, I can find out this one I'm saying. That's what he's saying. He has taken more than, I just asked him more, but only I need two only. Dice you told in terms of dice or joint probability. And joint too.
So the road matrix,
Huh.
we are getting 1 for
Okay. One the base paper you understand. So I have, this is 1, this is 2, this is 3. We have the fish thing. So only one face which is coming from top can be considered as one of the pillars, right? So but we have 6 faces. 6 faces we have. So 1 we are considering. So 1 divided by 6 we are making. So joint probability level. Multiple variables must be involved. So now dependency will be on both of them.
So we can create multiple variables by throwing the dice always 2 times. Always 2 times.
Correct. So dependency again will not be there. And we cannot say there are dependency. I mean joint. Obviously that is discrete. Discrete means both of them are independent. Both dice. This when I throw like this, it will not be affected. Like if it's coming to, it will become green. No, doesn't happen. Independent. This is different. This is different. Obviously, discrete separate. Right? So that's how you can understand. Got it? Okay. The calculation of joint probability is sometimes called the fundamental rule of probability or product rule of probability. Okay, joint probability, as we are multiplying 2 types of probabilities, we are calling them as rule of probability or the product rule of probability or chain rule of probability. Here P of A given B that we added in the formula is the probability of event A given that B has already occurred or B is becoming an evidence for A to conclude its probability. So B is becoming an evidence for A to prove itself is the acquisition. But we don't know A, but B is supporting it for A to prove itself or its probability. Clear? All right. B has occurred called conditional probability. Described here. A joint probability is symmetrical joint probability A of A and B is symmetrical, meaning that P of probability of A and B jointly is the same as probability of B and A. That is why we are calling them as symmetric. Same mirror image. The calculation using the conditional probability is also symmetric. Like if you do like this also or like this also, both will be same. Here we are giving A given B. Here we are saying B given A. Okay. All right. In such cases, in such situations, we'll be calling them as symmetric. So in joint probability, we are calling them as symmetric. All right. Okay. Any questions to discuss? Got it? Questions?
So,
Both.
both are separate.
The joint probability is symmetrical, meaning that P of A and B, you can write it, and say. And means what? Conjunction. So how do you say in conjunction? In terms of logic, if you speak, how do you say and? So in terms of sign, how do you write it? Mathematical sign we are using plus you write plus for multiplication. Multiplication. Minus. This one already.
For all it is plus
9. We did like this: A, B, Y. Triangle. Zero and zero. 0 and 1. For R. Two. All right. So, how about this one? What do you write operator if you are doing this one? Shall I write as multiplication here? I write plus. Okay, I'm talking about this one. There also. You do that and try to understand 9, A and B. Okay. So when I say 0 into 1 or 1 into 0, both of them are only 0. Answer will not change actually. Same thing here we are saying, if you write A given B or B given A, then we are saying the same thing. Alright? Then we have marginal probability, then we have conditional probability. I want all of you to understand this one. It's very important. Joint probability, marginal probability, conditional probability. All three are very important. Okay, we'll have 10 minutes more and we'll stop. Marginal probability. We may be interested in the probability of an event for one random variable, irrespective of the outcome of another random variable. Alright, you understand that? We may be interested in the probability of event for one random variable, for example, A. Example, x equal to A. X is my random variable, A is my event for all the outcomes of y. Where?
They have given the value for y.
They have given the value for y as a variable. This changing. So the event A. The probability of one event in the presence of all or a subset of outcomes, okay, of the other random variable is called marginal probability. This is my random variable, this is all random variable, and this is my event. Alright, how to understand that? I can understand that I have probability of one event. Probability of one event, for example, I have A. Okay, I have tossed coin once. That is my event A. Understand that? Next, probability of one event in the presence of the outcome of other random variable. Why it is saying presence of all? Presence means the outcome of other variable you already know. You already know the other presence of all the outcomes you know it. Outcomes you already know of other variable. Other random variable is called marginal probability of margin or marginal distribution. When you are trying to, they will be called as marginal probability. I am going to speak right now.
So random variable is the object and
Okay, that was the topic section.
random variable is nothing but the object.
Random variable on space ಇದೆ ಅದರಲ್ಲಿ ಯಾವುದೇ ಔಟ್ಕಮ್ ಬರ್ತದೆ. ಓಕೆ ಒಂದು ವೇರಿಯಬಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಅಷ್ಟೇ. ಒಂದು ವೇರಿಯಬಲ್ ಇದೆ a equal to 10 ಆಗಿದೆ. So I have 10 20 30 40 50 till 100 ಬಂದ ನಾನು ಇದೆ value. So I have that value, I have that variable in that any of these value can come 10 20 30 40 50 57. Any one of the value can come into the variables for a. My a is my variable and y is also my variable whose value is already decided and known. And when I cross, that is my a event b. So event a have so many possible values. Those values can be held in x. That is my random variable. That we have any outcomes can come into this because of the event. Okay. So what are we saying? Probability of one event in the presence of all or subset of outcomes in the other random variable is called marginal probability or marginal distribution. Okay. The marginal probability of one random variable in the presence of additional random variables is referred to as marginal probability distribution. Right? Why we are saying distribution? What is the meaning of distribution in English? Distribution, why should we say separation? Okay, separation or dividing. Okay, so as I say, multiple variables are involving in probability finding or possibility finding. So we are going to distribute their total control of giving the total answer. That's why we are saying distribution, right? Allocating the small amount of probability or occurrence. Alright, that's how it is going to go to that. Okay, further, it is called marginal probability. We are saying it is called marginal probability because if all outcomes and probabilities of all the two variables, I mean for two variables, were laid out together in the table, x as a column, y as a row. X as a columns and y as a one of the record. Okay. The marginal probability of one variable, that is x, that is one of the column, would be the sum of probabilities of other variables, that is y rows on the marginal table. We have Excel sheet and we have rows as well as columns, and we are trying to find out the probability or the marginal probability of one variable, that is x. That will be my one row, will be my one variable x. See, whenever I say an Excel sheet is having some numbers, that means I'm just say if I just have one row, for example, one row if I have, and I'm saying I'm considering one column. So how many numbers do you have? Only one. I cannot say it is a variable. I cannot say a column as a variable because the value is not changing. I don't have even two rows. In one row I have number is not changing, so that will not become a variable. If it is having at least two rows, one line and second line, then I can say okay, previously it's 10, I will see the 20, so I can say I am going to change the values. So I have a variable here. So when I have, for example, I have 10 rows, then I have 10 values being changing in the first column. So the first column is my column name itself is my variable. Here I am naming the first column as x. Alright. Okay. Here I have here we have statement marginal probability of one variable, that is x, would be sum of probabilities for the other variable y rows. Okay, on the marginal table. Understand? There is no special notation for marginal probability. It is just a sum of union of all overall probabilities of all the events for second variable. For second variable, for a given fixed event of event for the first variable. How do you represent that? You represent like this. The same thing that we saw here. X is my random variable, A is my event, and this is my all in Y. P of the probability of X equal to A equal to sum of probabilities of X for all Y or small, all the small events that we have. All right. Okay. This is another important foundational rule for probability. We are calling them as sum rule. But here, for joint probability, we are calling which rule?
And implications.
Okay. Here we are saying sum rule. This is OR rule. How about the joint probability?
And this and
Fine. Okay, let us go back to the slide and read this same statement in double quotes. We have product. So remember that this is product rule for joint probability. Marginal probability we are calling it a simple sum. Okay, it is different from the conditional probability describing the next. It is considered union. Consider union of all events for second variable rather than the probability of a single event, which are multiple. That's why it is marginal probability. Alright, basically you can find out marginal probability when you know all other probabilities other than the one that you are trying to find. Got it? Why multiple columns we have? We are just consider only one, but how about others? We don't know how many numbers are there, so don't know its height. Alright. Number. Okay. This I have explained so many times. Now you tell me what is this? Conditional probability. Probability you understand. Condition also you understand. Conditional probability. So there must be a condition, then only I can find out the probability. Okay. We were interested in the probability of an event given the occurrence of another event. Okay. If you give me one event, I will find out this event. Yes. The probability of one event given the occurrence of another event is called conditional probability. The conditional probability of 1 to 1 or more random variables is referred to as conditional probability distribution among multiple random variables if they involve and divide the total control of finding the probability into multiple variables. When everybody will join, then we can say one answer as one probability. Else it will be distributed among multiple variables. A is dividing some 10% of probability. B is having 30% probability is contributing, saying that it is true. Another is contributing 40%, another is contributing 30%. So total it is making it is 100% probability. Okay. Example. Conditional probability of event A given event B is written like this. So you already did this earlier. The bar is given as the pipe symbol and be read as given. We saw that yesterday. So written as calculated as probability of A given B equal to probability of A given I and B divided by probability of B. You can calculate.
probability of B is 0, then probability of A is 1.
Probability of B is
If
0.
probability B is there, then only the probability will happen.
Obviously, because the dependency is there. The definition itself says I am dependent on B, so we cannot leave that B. So B cannot. That's one reason. Another reason is it is the denominator. You know, everything is goes. Okay. Yes. Example is not possible. Okay, the notation of event A the notation of event A given event B does not mean that event B has occurred. Example is certain. Instead, it is probability of event A occurring after or in the presence of event B for a given trial. Okay. Understood? Condition probability. So we have three concepts. You need to remember them. Giant probability, probability, condition probability. Alright? So all of them are very important. When we read in terms of explanation also in theory of machine learning, we need to understand what we are reading. Okay? Because we talk there in terms of events. And in example also, when we take an example theoretically, we take example of events. Like somebody is burglar has entered the home and there are sensors available and those sensors are detecting even if the other persons are entering at the night when the lights are off. When the burglar is also coming at the night and he's also being said that he's the thief and the people in the home also thief. So how do you differentiate the two events? So such many examples are there and you will be able to enjoy it. But still, you understand the concepts in a very short explanation. A is the event, B is the event. We are not saying what is A and what is B here. Simply, we are telling you to imagine there is an event, like I am just taking small example of task, will be an event. But there are a lot of events that you can imagine. Alright? Okay, let's finish this topic till here. And we have probability of independence, and exclusive. You understand both the word? Independence, you understand because every year we say it. Exclusivity. Both are obviously. Exclusivity. Anybody? Meaning? Exclusive. Have you seen in Canadians? Exclusive. Alright, that is exclusive. Exclusively available. Exclusively, we have taken the what you can say? New things. Special things, new things, or only original things, right? Original clip, original video, right? So exclusivity. Exclusivity means the rights belong to the same variable. Okay. When considering multiple random variables, it is possible that they do not interact. It's possible that they do not interact or they are independent variables. Okay. Like I told you, two dice, when you roll it, both of them do not dash each other, right? They do not interact with each other, but still they give the outcomes. They are independent variables. Okay, so then we can say them as a probability of two independent events happening. We may assume that two variables are not dependent. We may know or we can assume initially are dependent upon each other instead are independent. Obviously, you can consider them as independent initially. Alternatively, the variables may interact, but their events may not occur simultaneously. Referred to as exclusivity. Exclusivity means two events are interacting. Okay, but the events are happening one after another. That means at specific time, one outcome can come. That is reserved. That is fixed. That's what we are saying. Exclusivity of giving outcome at a time one, even if they interact. So that's what we are saying. Independent and dependency of two events giving rise to the outputs. Alright, that's what independence and exclusivity says about probability of multiple events happening at a time or independent of each other. Got it? You're learning or just saying this?
Yes.
Learning? Because it is needed, it's mathematics in machine learning. Even if you this much if you explain, in interview when they ask, it is more than enough because their concepts are easy, but the focus and the time that you want to learn that is very important. The focus is very important because whatever things you are thinking and you are asking something when you don't know and you are still trying to understand everything and giving some examples, this will solidify the knowledge base that you are presently learning. That is difficult for most of your opponents who are coming with you on it.
So the statistics is the job paper in MLC.
Yes. Without this one, you will not be able to understand. You may execute it and you may show the output. When I tell you understand and tell me how it is working, then you will not be able to imagine anything. You don't have material to imagine. You don't have material to imagine. How do you imagine? You need fundamentals, right? You need these fundamentals. Now, at least you are giving examples. If you do not read this properly, you will not be able to give example because example are application of the concept. That is the thing. If you give example, immediately understand that, you apply that, and you have given example. That means understand. That's my take to measure it. Okay, the learning outcomes. I also have probability in my class. I find out the probability. I have the possible outcomes. I have the learning outcomes. Number of students versus number of understood students. Probability I check it and I use my remaining reference and open it. If a few people understand. Okay, independence. If one variable is not dependent on a second variable, this is called independence or statistical independence. Statistical independence, obviously, they are talking about the numerical independence. The values which are not changing or affecting, the other value changes, right? The variable changes. This has an impact on calculating the probabilities of two variables. Example we have taken here is we were interested in the joint probability, which are obviously explaining about dependency of each other, of independent event A and B, which is the same as probability of A and the probability of B. Okay, we may be interested in the joint probability of independent events, that is event A and event B, who are actually operating independently, but they are jointly giving the probability using multiplication. Right? Therefore, joint probability of independent events like event A and event B, two independent events, is calculated as a probability of event A multiplied by probability of event B. Where we saw this? In joint probability, we saw productivity. Right? This is what they are telling. That we are going to multiply. Okay, joint probability is this one. As we might include the marginal probability of an event for independent random variable is simply probability of the event, joint probability. It is the idea of probability of single random variable that are familiar with the marginal probability. Marginal probability is we refer to marginal probability of independent probability as simply the probability. The conditional probability of A given B when the variables are independent is simply of A as the probability of B. Alright, focus. Same as conditional probability, A given B equal to probability of A. You are trying to find out the A with the help of B. With the notion that, okay, we may be familiar with the notion that statistical independence from sampling. This assumes that one sample is unaffected by peer samples. Have you heard of it? Right? You understand that, right? Okay. Assume that the samples from random. Okay. Oh, samples unaffected by the peer samples and does not affect the future samples that we are taking from the data sets. That will be one of the event, obviously. When you take a sampling in the data set, that will be one of the event. But that event or that event doesn't affect the another event or sampling of new data set in the same process. Process is same, data is same, but sampling we are doing differently. That will be one of the events. So that we are considering as shared probability, conditional probability. Many machine learning algorithms assume that samples from same domain are independent to each other and come from the same probability distribution. Same probability distribution means the whole column is one total possible samples we can fetch it from the whole column, and we are going to take some samples from the whole column, and that's why we are saying whatever outcome is going to come, that will be the total outcome, and the space that we are considering will be the independent of each other, and we are calling them as probability distribution. The probability is distributed among the whole data set column because we are taking samples from the same column, as we are considering the whole column as the probability space or sample space from which we are taking samples. You understand that? Samples from the same domain independent of each other and come from the same probability distribution, and we are calling them as independent and identically distributed. That is for short, you can understand they're independent, but they are dependent overall in one column. Obviously, they are in one column because the whole column says I will give you one probability, but in between, what we are doing, we are just taking a sample of it. For example, I have 1000 numbers. I am taking 200, 200, 203 times. Totally, I have 1000 numbers probability, one probability I have 100%. But I am taking 20%, 3 times samples. The 3 samples that I have taken are also the part of probability of the whole 1000 numbers. 1000 numbers is one probability total, but I have distributed them among these 200, 200, 200 numbers. I distributed them. Whatever distribution you are getting, when you add them all together, then you get a total probability. So since we distributed them, so we are calling them as we distributed them as a probability. Fine. Why do we sample? We heard it earlier. Sampling. We spoke about one of the example of OT. Recently, OT happened. An election happened. We spoke about to find out the what is that pre-voting polls, exit polls. Exit poll we wanted to find out. So we spoke about that example earlier. In different districts, we'll go and ask people who will win. Then we samples the collecting from whole of Karnataka. Karnataka has a lot of districts. Some from here, some from here. Everywhere we just collecting. Totally Karnataka 100%. Some of the voices are coming that these party will come. So they are small voices are coming and collecting. And we are saying they are distributed. I cannot say by coming to me and asking people, I can't say this party will win. Bias, right? So what other people are doing, I don't know. That's how the whole Karnataka I consider as 100%. So only Hubli is 10%. 90% are not surveyed. Go and get the 90% survey. Then we say 100% survey. Total conclusion we take down. So my probability is distributed in Karnataka. Karnataka is 100%. I just taken my probability of the party will come 10%. Because we say one party will come. I can say 10% confident that this party will come. Over 90%. I don't know. It is distributed. When I get all the data, then I can say all the distributed data has been collected. Now I can say I measure them and I give you total probability, which is earlier distributed in different districts. Alright? That is what we are saying here. Statement. In many machine learning algorithms assume that samples from domain are independent to each other. Okay, and come from sample probability distribution. Sample probability distribution. That's why they have been referred to as independent and identical distributions or distributed. What? Or IID for short. That is independent and identical distribution. IID. Got it? That's how it is being understood. Exclusivity. Exclusivity. You understand that? Exclusivity. If the event excludes, what does that mean? Exclude. Include, exclude. Include means including. Excluding means removing. Okay. If the occurrence of one event excludes the occurrence of other events, then the events are said to be mutually exclusive. What does that mean? It means like this. I am in my engineering college, or in my BCA college, or MCA college, or engineering college, or one of the college, in diploma college also. One of my close friends' birthday is there, but one of the enemies also going to the function. Now you tell him, will I go or not? No, obviously.
You go, he will not.
He will not come.
He comes, you will not come.
If he gets to know that I will come in, he will not be coming. That is mutually exclusive. Let us read ahead. If the occurrence of one event is not very clear. Yes? Okay, the probability of events are said to be disjoint, meaning that they cannot interact, are strictly independent. Alright, let's understand again. Probability of events, any events, are said to be disjoint, meaning that they cannot interact, are strictly independent. Whichever events are disjoint, they are strictly independent, do not interact. If the probability of event A is mutually exclusive, probability of event A, B, means what?
A and B are opposites.
A and B are opposite. Exactly. Okay. Then the joint probability of event A and event B is 0. Okay, both cannot handshake. That's what it is. 0. Probability of both meeting at a place and partying is 0. Okay, probability of A and B is 0.0. We agree. Instead the probability of an outcome can be described as an event A or event B. Stated that probability of event A or event B equal to probability of event A plus event B. That's what we can say. We can add them and we can try to give the value. The OR is also called as union. Obviously, in terms of mathematical set theory, we call union prediction. Okay, union and is denoted as capital U. Capital U. Letter, for example, A or B equal to A union B. If the events are not mutually exclusive, we may be interested in the outcome of either events. Right? If the events are not mutually exclusive, means what? They are not opposite.
He will also come there.
Yes.
If you decide not to go there, then he will also drop his plan to go there.
Obviously. That is mutual exclusion, not mutual exclusion. Okay, the probability of non-mutually exclusive events is calculated as the probability of event A and the probability of event B minus the probability of both events occurring simultaneously. Probability of non-mutually exclusive events total is calculated as the probability of event A and the probability of event B minus the probability of both events A and B occurring at a time. Alright, that will give the non-mutually exclusive events. Event A and event B minus event of both A and B together. This can be stated formally as probability of A or B equal to probability of A plus probability of B minus probability of together A and B, joint probability. Then we are calling them as non-mutually exclusive probability. Okay, then we have probability distribution. This we'll see next. All right. A lot of probabilities, right? You might have not thought that before 5 minutes I will be late. So that's probability. All right. Thank you for joining today. We'll stop here.